So finally, we've made it to compilers. We've made a few references to them. Let's actually define what a compiler is. So a compiler is a piece of software. It's a specialized program that translates source code. That's what we're going to be writing in this class. So the source code is written in a high-level programming language. Again, Java's not the only one. There's tons out there. And so the compiler is the one responsible for translating that into a language that computers can understand. That's machine code, right? The binary that we discussed. So if a computer is going to actually execute and follow through on those instructions, we got to translate it for it. And that's the job of the compiler. So there are different compilers depending on the language you're using. Clang is for C and C++. Java C is for Java. That's the Java compiler. Python has an interpreter, but there's also a compiler step when compiling Python code. So depending on the language, right, it's going to have a different compiler. But they all kind of do the same thing. They're all just translating that high-level code down to that low-level machine code. All right, so we're actually going to get all the tools we need for Java through the JDK. So that's going to be what you install for this week's lab, right? For your introduction into the class, we got to get ourselves set up with Java. So we're going to do a JDK download. Don't worry, it's free, right? As is with a lot of open source software tools. It's ready for anyone to use, and we're going to be walking you through on how to actually download the JDK. It's pretty simple. So the key components that you'll get in the JDK are the Java C. You'll get Java, which is the runtime interpreter. You'll get the Java jar, which is a tool for Java archives. Java doc, so when you start to write comments and you want to document your code, that's when you kind of explain code to other people. Java doc, that service is there to generate documentation. Documentation, again, it's just a guide so other people can come to your code and understand what you wrote. So that's all part of the Java development kit. So yeah, it's a package that provides all the tools for developing, compiling, and running Java apps. It also includes the Java runtime environment, the JRE, that you need to run the Java applications. Also includes a lot of standard Java libraries. So when you're coding, you don't have to do everything, down to the lowest level. Java has some like predefined libraries, commands and codes that we can use that are extremely useful for any developer. Yeah, the download button is here. It'd also be here it'd also be on the lab as well. But yeah, if you're curious on checking the JDK while you're here on the slides, you can just click on this icon here, that little link button. So yeah, how do compilers work, right? Now, once we get to downloading stuff, we need to understand how all this stuff works. Well, you write your source code. You're going to write it in Java. So that's going to generate a source file, right? And then you're going to run your document through a source code compiler. So that compiler checks for errors. Again, if you make any syntax errors, the translator is going to be able to identify those because it won't be able to translate them. So once it's satisfied that everything runs correctly, it's going to move into the next step, and that's going to be the output. So the compiler is going to create a new document called Java bytecode, so that any device capable of running Java will be able to interpret and translate that bytecode into something that into actual instructions, right? Something that the computer can do and run. So the compiled bytecode is platform independent. It doesn't matter if you're running on Mac, Windows, on desktop, on a server computer, right? Java code is write once, run anywhere, WARA. And then, of course, if we're going to actually run this code, we're going to need not a physical Java machine, but something called a virtual Java machine. So that's just a piece of software that runs on your computer, and it makes it easier for your device to actually run the bytecode. So these are the four main steps of compiling code. We have our source code, we have our translator. The translator generates that code for the computer, and then it's going to run on the virtual machine. And then there's several layers, right? Eventually, that computer is going to read it as actual binary code. We're not going to go through every single step, right? But if you do have more questions about how computers read code, definitely watch this video from Frame of Essence. Just a little bit, another diagram here, right? We have our source code file. That's going to be .java files. It's going to compile, right? It's going to run through the compiler. If it's successful, it's going to generate a Java class file. And then once that class file is generated, the Java virtual machine is going to use the interpreter to actually interpret that code and see, hey, what do you want me to do? It's going to send that to the operating system. Operating system sends it down to the hardware. A lot of these terms, right, we don't really discuss in this class. I do discuss them again. I'm going to say that many times in this class, the 101 course, especially in the beginning, right, of a lot of these introductory computer classes.